False positives and false negatives. These are most probably discussed in terms of maybe medical testing. A false positive, okay, so let's color code these. A false positive is when you test positive, but it's wrong. So you go in and the doctor says, yes, you are pregnant, but you're really not. That would be a false positive. Okay, a false negative. You test negative, but it's wrong. That's the key of it. It's the whole false piece. So you go in and the doctor says, you are not pregnant. And you're like, oh, okay. And then 9 months later, you have a baby, right? So, or 6 months later, depending on how far along you were. So test negative was when they say, no, you're not pregnant. No, you do not have strep throat. No, you do not have cancer, whatever. But they're wrong and you really do. So when you think about which one is worse, it probably depends on the situation and what you're testing for. So we're going to start with kind of an HIV test here in this first piece. And the accuracy rate of the test is 99%, right? Nothing is perfect. So think about this logically. If you have HIV and you go to the doctor, you would expect to test positive. That's the same for anything. If you're pregnant and you go get tested, you would expect to test positive. If you have strep throat and you go to the doctor, you would expect to test positive. So the accuracy rate is where things should happen. If I have HIV, I should test positive. That intersection right there is where our first 99% goes. If you have it, you should test positive. So, but if 99% people test positive, that means 1% test negative. And if you do not have HIV and you go to the doctor, you would expect to test negative. So that's 99% accurate. But unfortunately, 1% of people who test negative will still test positive. Okay? Now, where do the false positive, false negatives come into play? Well, testing positive, but being wrong. If you test positive, it's wrong if you really don't have it. So this is where the false positive comes in. It's positive because you tested positive. It's false because it's wrong. Now, in the negative column, we're looking at a false negative. If you test negative, you expect to not have it. So if they say you do have it, that's where the false negative comes in. Okay? So let's play with some numbers here. In reality, a very small percentage of the population has HIV. In America, only 0.5% of the population has HIV. What percent does not have HIV? Well, we have 100% of people, right? We have all people. Only 0.5% have HIV. When you subtract those, you get 99.5%, which means this is the percentage that does not have it. Does not have HIV, 99.5% of the population. We're going to use these percentages to answer some questions. So, suppose 100,000 people go in and are randomly tested for HIV. Based on the if 0.5% of people have HIV, how many out of 100 would be expected to have it? So this is 0.5% of 100,000, because that's how many people we're talking about. Well, recall that when you play with a percent, 2 decimals to the left. So this is 0.005. Of means times, and we're going to multiply by 100,000. So we find out that 500 people should have HIV. Okay? Based off of this percentage. So, how many of those with HIV will test positive? And now we got to think back on our accuracy rate. We had a 99% accuracy rate. So, if you have it, we would expect you to test positive. So, 99% of the 500 will test positive. Well, they should, right? So, 99% is 0.99 multiplied by the 500, and we end up with 495 people will test positive. When you're thinking, but wait a minute. Exactly. You have 500 people with HIV, 495 of them tested positive, which means 5 will test negative. So these people tested positive, 5 tested negative. And you can imagine these people, they go in, they're told, no, you do not have HIV, but really they do, right? So we have some issues there. We'll talk about those issues in a minute. Now, let's go back and say, okay, how many people out of 100,000 would not be expected to have HIV? Well, we can do this two different ways. We know that 99.5% do not have it. So 99.5% of the 100,000. So you could take 0.995 times 100,000 and get 99,500. That's one way. Or you could say, I have 100,000 people total, and I know that 500 of them have HIV, which means 99,500 do not, right? Either way, this is the amount that do not have HIV. So I'm going to do number 8 first. If I have 99,500 without HIV, right, these people do not have it, 99% of them will test negative. So we're going to multiply that by 0.99, because that's what should happen. If you don't have HIV, you should test negative. So 99,500 times 0.99 gives me 98,505. And that's what should happen. If you don't have it, you should test negative. So let's go up to number 7. We had 99,500 without HIV. 98,505 of them tested negative, which means 995 people will be told you have HIV when in fact they don't. Okay? And you might be saying, this is a lot of information to keep up with. You're right. Let's put this in the table. So forget this bottom part for right now. We'll come back to that. But based off our numbers 3 through 8, we know that 500 people are expected to have HIV, which means 99,500 are not expected. You see those two numbers add up to 100%, or 100,000, excuse me. Okay, and we got that from numbers 3 and 6. Now, in the top line, if you have HIV, you would expect to test positive. So this is where the 99% times 500 came into play, which gave us an answer from number 4 of 495. If we have 500 total, 495 tested positive, then 5 tested negative. Okay. In the second line, those that do not have HIV are expected to test negative, so that's where the 99% times 99.5 came in. And when I multiplied that, it gave me 98,505. And then the other ones had 995. Okay? So recall, here is our false negative, because you tested negative but you have it. Here is our false positive, you tested positive but you don't have it. Okay, so using that, let's answer some questions. How many positive test results are there total? Well, that means I need to add. So if I add all of my positive test results, I end up with 1,490. 1,490 people total will test positive. How many negative test results are there? Well, if I add those up, I get 98,510. So 98,510. False positives, we already talked about that. There's 995, and there are 5 false negatives. Remember, when you're talking about the false positive, false negative, the positive or negative tells you what you tested. Did you test positive or did you test negative? And then it's just wrong, right? Okay, let's do some probability. What is the probability of having HIV if given a positive test result? So I'm only talking about my positive test results. I have a denominator of 1,490. Having HIV, that's on the top, 495. So that's a 0.33 or a 33% chance. Meaning if you go to the doctor and they say, I'm sorry, Sarah, you have HIV, you really only have a 33% chance of having it. So I would say I would like to test again, because if you test positive twice in a row, yeah, that's a little bit different. But only one positive, not necessarily. This is why people get second opinions, because there is the possibility of you being wrong, and depending on the test and the numbers, there's different probabilities. So what's the probability of not having HIV if given a positive test result? So again, we're in the positives, denominator 1,490. Not having HIV is 995. So that gives me 0.67. You will see, oops, wrong button, 33. This is testing positive with HIV, testing negative with HIV. Those add up to all their complements, right? Okay, let's go if given a negative test result. So let's talk about our negative test results. Having HIV. Having it over the total of negative testers gives me 1, 2, 3, 4, 5. Super, super small decimal there. So if you go to the doctor and they say, Sarah, you do not have HIV, you can be pretty confident of that, I think, because there's such super small chance that you actually have it. If given a negative test result, so again, 98,510 is my denominator, not having HIV, so the 98,505, we're talking about 0.99995. That's a 99.995% chance that you don't have it. And I think that's pretty good. And I believe that is, oh, I lied. Which error is worse, a false positive or a false negative? Now, this is completely and totally opinion. Remember that a false positive is when they say, Billy, you have HIV, but you really don't. So if you're told that you have HIV and you don't have it, I mean, one, it's going to crush you, right? It's going to crush your family, your friends, just because, you're sick. You have a disease, and that's sad. Nobody wants that. But you're probably going to start medication and start treatment and all of that. And it's going to be sad and depressing, but you really don't have it. So eventually you're going to figure out that you don't have it, and life hopefully gets better again, hopefully. Now, if you have a false negative, you're told, hey, Jacob, you don't have HIV, go live your life. And you go out and you have unprotected sex, or you share needles, or you bleed and somebody with a cut helps you because you're not infected, and you transfer. And you're not being treated. So you have the potential to spread the disease, first of all, which is not good. And you have the potential of dying quicker because you're not being treated, right? So I personally think a false negative in this case is worse because you have a potential to infect others, and you're not being treated for what you have. The false positive, I'm not saying that's good because it's going to really harm your life, but mentally more so. A false negative is going to harm more physically, where the false positive is going to harm more mentally. So, I mean, they're both debilitating, but, it's kind of opinion of which one is worse. So there is your intro, false positive, false negative.